I think we can get started now. My apologies for the delay. Not sure they picked the right room given the size of this audience, but I probably would have done a worse job. So what we're going to talk about in this session is basically OAuth as it's implemented in SharePoint 2013. So we're going to start just with a discussion about app authentication. Now, I included a whole bunch of slides because I thought that not everybody here is going to be rock solid in their knowledge and skills for building SharePoint apps. For many of you, this week is the first time you've really kind of seen SharePoint apps, yet understanding how SharePoint apps work is a prerequisite for this talk. So I'm probably going to have to go pretty fast through many slides just to kind of give you the background. We'll talk about requesting and granting app permissions. We're talking about, in the middle of the session, just at a high level, how does OAuth work? How does the handshakes work? And then we'll talk about developing SharePoint apps that use OAuth and how we write the code and what are the things we have to put in the different web.config and the app manifest files. And at the very end, there's just an ad hoc topic about when you have something that's not a SharePoint app, it's just a website on the internet, and you want that to be able to talk to SharePoint. I'll show you how to basically request and acquire permissions on the fly. Okay, well, let's start with a quick discussion of SharePoint 2010. SharePoint 2010, we didn't have apps yet. We have SharePoint solutions, and there's lots of SharePoint solutions. Some farms love solutions. Some farms say, absolutely not in my farm. But one of the big problems that we have is that SharePoint solution code runs on the server. So we have issues with code compromising the scalability and the reliability of the farm. We have issues where code in solutions gets hard-coded to assemblies, which makes it very hard to migrate to the next version. But from the security perspective, there's other big problems as well. And that is, SharePoint solution code isn't recognized as an independent identity. Therefore, you can't configure permissions for the solution code. You always have to rely on the permissions of a specific user. Now, if you allow me to write a farm solution and deploy it in your farm, well, I can call this SP security run with elevated privileges, and my code runs as God and can do whatever it wants. So there's plenty of people that have a big issue with that. Well, how about if you put me in the sandbox? If you put my code in the sandbox, it always runs as the current user. I can't elevate permissions. And so you have this issue where when someone activates my sandbox solution, they have to be a site administrator to activate it, and my code runs as them, and I can perform an attack by basically deleting every piece of content in their site collection. But later on, when the code starts running, and we just have a lowly user like a contributor or a visitor, the code inside my sandbox solution has to run as them and probably can't do a lot of things it needs to do. So there's this basic issue with SharePoint solutions that code can't be recognized as its own entity, its own security principle. And so that's one of the big motivations of moving to the app model for custom solutions. So if we just, within 15 seconds, remember what is authentication and authorization. So authentication is a process that the system uses to establish an identity. Okay. And it's typically performed on a security principle, like an Active Directory user. Authentication always has some form of a receipt, some type of security token. Maybe a Windows security token, maybe an FBA security token. And that basically gives the user a badge, and the system uses it to understand the identity of that security principle. Now, once we understand the identity of a security principle, well, then we can configure security and an authorization system based on access control lists. Now, in SharePoint 2010, we support authentication and authorization only for users. In SharePoint 2013 now, we support authentication and configuring permissions for apps as well as users. Now, what is a security principle? Probably thought about this a couple times. Some kind of entity is understood by the system. And it's an entity that you, in many cases, can configure permissions. So you can keep different security principles out that you don't want and let certain ones in. So when you think about security principles, well, users, that's pretty obvious. Active Directory groups, FBA groups. Well, if you add a computer to a Windows Active Directory domain, it becomes a security principle. And so what we're going to see now is with SharePoint 2013, apps become first-class security principles. And that's a requirement if we're going to be able to configure permissions to basically dictate what apps can do and what they cannot do. Okay. Now, just a little bit more background on user authentication. So in 2010, we have two different ways to create a web application: claims mode and classic mode. Claims mode basically takes the user identity and maybe it authenticates against Windows and Active Directory or against FBA, but we basically convert that user identity into an XML document using a language called Security Assertion Markup Language, or SAML. The older style, the classic mode, doesn't create SAML tokens, basically just creates a Windows security token and leaves that there. So what we see is Microsoft is making a big push to say, well, we're still going to let you run classic mode, but we're really recommending that you don't. You can't create classic mode web apps through the UI. You've got to create them through PowerShell. Oh, and by the way, SharePoint apps don't work in web applications that are in classic mode. So we have to have a claims mode web application so we can establish user identity in a fashion that SharePoint apps require. So when we get to SharePoint 2013, so we have app authentication where apps are going to be recognized as first-class principals, and that's going to give us a basis for doing authorization. Now, a very important aspect is that an app, whether it's running JavaScript code in the browser or it's running C# code over across the network, in its own app server, has to call into SharePoint through the client-side object model or the REST API. Only those entry points are basically doctored to have a processing pipeline to do app authentication. So apps have to use those entry points. And another thing to note is that if you have a developer who creates a custom web service and puts it up there, the app cannot call into that and be authenticated. So it's only the out-of-the-box CSOM and REST API entry points that support this. Now, there are three different types of authentication. There's internal authentication, there's external authentication using OAuth, and there is external authentication using S2S. So I have to talk a little bit about internal authentication just so you understand what it is and when it's used. And then the second half of the session, we'll drill down on OAuth. And then in a separate session I'm doing after this, we'll talk about S2S, external security. At a high level, you could say OAuth is what we use in Office 365, and S2S is what we use on on-premise farms. With a little caveat is you can do some extra work and configure the on-premise farm to also support OAuth. But in general, OAuth for Office 365 and S2S for on-premises. Okay, now here's a quick background. When you create a SharePoint app, there's two types. There is the SharePoint hosted app, which everything is contained inside of SharePoint. When you install it, the app adds all the resources it needs, like web pages and JavaScript files, into the SharePoint environment, into a special site that's created when the app gets installed, known as an app web. SharePoint hosted apps don't have a server-side presence. So they can have client-side code, but no server-side code. And typically, all the code in a SharePoint hosted app is written in JavaScript. And it executes on a page that's already been authenticated as a particular user. Cloud-hosted apps have a server-side component that runs somewhere, anywhere it wants to, as long as it's outside of SharePoint. Now, that external website that's associated with a cloud-hosted app has a particular name. We call it the remote web. And it can have both client-side code on the pages served up from the remote web, and it can have server-side code that runs inside of the remote web. And what most developers will do is create the remote web using ASP.NET so they can write their server-side code in C# or VB.NET. However, the high-level design of this app architecture makes it so that you're not tightly coupled to Windows or .NET or ASP.NET. So you could create your remote web on a Unix box, using any technology that you want that you could stand up a website. You will find that .NET and the support that they've added, for ASP.NET projects makes it infinitely more straightforward to create the remote web in C# or VB.NET. But in theory, if you have enough time and enough knowledge, you could create it using any platform that you want. Now, every app requires a start page. And what we'll see is that since the SharePoint hosted app has to push all its resources right below where it's installed, which we call the host web, and it gets installed into that child site known as the app web. So basically what's going to happen is when an app gets launched, SharePoint just redirects you to the start page in the app web. But with a cloud-hosted app, SharePoint has to remember where the remote web is across the network, and when you basically launch that, it's going to basically bootstrap you into there. Okay, so that brings us to our first demo. Okay, so here I am over on my demo machine, and I'll start by going to my Office 365 preview site. So I've got this Office 365 site, and when you want to do development work, you have to create a special type of site, which is known as a developer site. Note that when you create your preview in Office 365, you don't just have one site collection, but you have a tenancy with an administrative site collection, and you can create other site collections inside there. For instance, if I went to SharePoint admin, and it's going to show me the different site collections that I've created inside here. The one I'm going to be using in my demos is Ted's dev site. Note that if I call new right here, and I create a new private site collection, I can create a new private site collection, and it's important I use the developer site. The main thing that distinguishes the developer site is when you're using Visual Studio, it doesn't have to be on the same machine as the SharePoint farm. The developer site is the only one that supports Visual Studio being over here, and basically during the development process, installing the site over there for testing purposes. So if you have an on-premises farm, you can optionally use the developer site. When you're in Office 365, unless you have a good buddy inside the Office 365 environment, you're probably not going to start up Visual Studio on the remote servers there. Okay, now let's go over here and take a look at my dev site right here. Okay, so you can see there's my dev site. There's this particular URL to my dev site. I'm going to go ahead and start up Visual Studio. Note that if you're doing development work, it's even more important this time around than in 2010 to start Visual Studio as administrator. So I'm not going to use OAuth in this first sample. Let's just create something real simple, which is a SharePoint hosted app. So what I'll do is I'll come down here, I'll create a new project, and under C#, Office SharePoint apps, there's my app for SharePoint, and we'll call this one something like Hello SPC, and I'll go ahead, choose OK, and then in this next one right here, it's going to ask me, where do you want to debug? I point to my site up there. What are you going to do the presentation better than me? Just kidding. Okay. I went back to pink. That's horrible. I'm homophobic. You can't make it pink. Okay, there we go. I guess I don't have to stop while you're doing that. Okay, let me go ahead and choose Finish right here. So on my machine, it creates this Visual Studio project. And what you're going to see is just a whole bunch of files that the SharePoint hosted app needs. And it turns out that I really don't have to write any code. Microsoft has done a pretty good job of allowing me to create the new project and hit F5, and then charge an hour and a half of billable time. Okay, so I come back here. Notice that there's this particular page down here. If I look at this thing called the app manifest, let's go ahead, look at that. You can see that there's a start page that points to this thing called the app web. Let's go ahead and hit the F5 key. That's my start of debugging. And so as this thing loads inside there, you're going to see that there's just some minimal code inside here. And I'll just show you this code. And this code basically uses jQuery and the document-ready event handler to basically fire this other piece of code right here. And they're going to use the client-side object model, CSOM, to make a call. And one of the things that I want you to see is that there's absolutely no code that has to be written to deal with the authentication. Okay, now let's see how we're doing progress-wise. If I come back here, a lot of times the first time you move inside there, it's going to take some time. But now I come back here. There's my particular app. And while it's not all that exciting, you can see that here is the code that has run. The code that has run basically just used a get user and then made a CSOM call inside there to push this out. So we've basically made a call from the browser back into Office 365. But now what I want to point out is look at this URL inside here. There's this very special URL. Okay, so let's go back to the slides now. So what happens when you install a SharePoint hosted app? You have to install it in a specific site. And under that site, during installation, they create this special thing called the app web. And that's where the app basically adds its start page, and it can create SharePoint lists, SharePoint document libraries. It can add basically anything declaratively that you would add in a SharePoint solution. Now, SharePoint-hosted apps have to have an app web, or they won't work. Cloud-hosted apps don't have to have an app web because they could live on the remote web. Yet, a cloud-hosted app can optionally create an app web, and there are quite a few scenarios where the cloud-hosted app needs an app web. And you could simply go and add something as simple as a list or an empty element, and just having one thing inside of your app project is what triggers the creation of the app web. Now, if you look at this URL to the app web, well, here's the one for my site right there. Ted Pattison -somebigNumber.sharepoint.com/site/Ted'sDevSite. So what they do is they create this URL on the fly as the SharePoint hosted app is being installed. And the URL is made up of a couple pieces. First one is the name of the tenancy. So since it's my Office 365 tenancy, it's Ted Pattison. Then they create this unique identifier, the app UID. And every time you create an app and install it, you get a new one of those. If you install the same SharePoint app in two different sites, there'll be two different app UIDs. So really it's the installed instance of the app ID as opposed to the app project ID. Also, the farm that you're installing has some type of domain that it's configured to run apps. And in Office 365, it's oasharepoint.com. And then there's going to be the offset to your site. Could be at the root. Mine just happened to be off sites, Ted's Dev Site. And then there's the name of the app inside there. So now that you've seen that, why do they create this funky URL? Why can't I just go to the site and then say /appweb1 and get inside there? And it has to do with them being able to perform a simple type of authentication, which is known as internal authentication. So first of all, what are the scenarios where they use internal authentication? Client-side calls from pages in the app web are the most common. However, there's other scenarios. I'm not going to have time to kind of go into them in much depth. But if you have a page that is served up from the remote web, it can use this special JavaScript library called the cross-domain library to basically issue calls through the app web, which then can act on the app web or the host site. And then also, if you have an on-premises farm and you don't want to configure external authentication, you could basically have server-side code call back into the app web and use it. And the idea is that we need it for SharePoint-hosted apps and for other cases where we just either don't want to or for various reasons can't configure external authentication. So how does it work? So first of all, the incoming call has to be authenticated as a user and have a SAML token. Secondly, when the call comes in, SharePoint realizes that it maps to a URL that maps to an app web, that maps to an installed instance of an app. So one of the main reasons that they do this is that when they see calls coming in, they can just use this internal mechanism to say, hey, this is targeting app number 123, therefore we'll authenticate the call as app 123. Now, one of the main things that makes this work reliably is that within the browser, we have cross-scripting restrictions so that an app page served from domain 1, can't, have free access to things from domain 2. And another thing to point out here is that when you're using internal authentication, it's easy because your app doesn't require any explicit code for authentication. It just basically works. Now, before I said there's two types of apps, SharePoint-hosted apps and cloud-hosted apps. But now let's go into a little bit more detail. There's two types of cloud-hosted apps. There's provider-hosted apps and there's auto-hosted apps. Both of them can have server-side code. So what's the difference between them? Let's start with a provider-hosted app. With a provider-hosted app, the remote web runs somewhere on the network, somewhere on the internet. And typically, as a developer, you create a provider-hosted app project in Visual Studio, just hit F5, and during your testing debugging process, it just uses HTTP or HTTPS : localhost. But by the time we're ready to ship this thing, we then have to take the code for our remote web and stand it up somewhere on the internet and have it be at a well-known endpoint. And when the app gets installed, it has to have information it tells to SharePoint to basically say, where is the remote web on the internet, and what's the offset to the start page inside there. So one of the big things about the provider-hosted app is the developer or the developer's company takes on the responsibility of standing up the remote web and managing it over time. And then you can imagine with a provider-hosted app, if it gets really popular, you might have scalability issues. In most cases, provider-hosted apps have a custom database behind it. So you're not just responsible for deploying the website for the remote web, but also the database behind it. You might be responsible for backing up and restoring the database as well. So what's an auto-hosted app? An auto-hosted app is where Office 365 and some integration that it has with Windows Azure basically takes the responsibility of standing up the remote web and optionally creating a SQL database. And it basically says, as long as I can look in your app and its installation file, and I can find information about how to create the remote web and how to create the SQL Azure database behind it, I'll basically take that responsibility away from you. So the idea is when you create an auto-hosted app, when someone installs it in their Office 365 tenancy, Office 365 basically just stands up the remote web, and as a developer, it's not your problem. You don't have to stand it up in Windows Azure. You don't have to pay a monthly fee. You don't have to back up and restore. You don't have to worry about scaling things up. It's the customer's problem. Okay. What we'll see is that auto-hosted apps are really neat. And they just make things so much easier to get things set up. And in many cases, we want to use that just because we'd rather kind of push the responsibility of managing the remote web and possibly a database and push it off to the customer in their Office 365 tenancy. However, every customer gets their own database that then you don't have access to. So the provider-hosted app, you control the SQL database. You have a lot more control over how to go in there. If you need to do things like customer support, someone calls in. So you have a lot more control, but a lot more responsibility and a lot more code, especially when we have multi-tenancy, when we have one provider-hosted app and its remote web, and I've installed that auto-hosted app in 100 different customers in their tenancies, and then I have people from all these different companies calling into one entry point. So that definitely takes a long time to design around that. Now, finally, we can get to the point of external authentication. So external authentication is used for both OAuth and S2S. And it's used when I have server-side code that's running in the remote web that wants to call into SharePoint. So incoming calls are going to require an access token. The access token always carries the identity of the app, but it can optionally also carry the identity of the current user. If you're a developer, you have control as far as making calls into SharePoint with app plus user identity or with app only identity. Remember that all the calls have to target CSAM REST entry points. And the last thing is, I have children, so when I tell them something that's very important I want them to remember, I make it bold, I underline it, and I put it in red. Okay, your code is required to create managed security tokens. So unlike internal authentication, this requires explicit programming. Okay, now, there's three cases. Plain old user authentication, an app that gets authenticated using internal authentication, and an app that gets authenticated using external. And the first two cases have SAML tokens. The last case, there's no SAML token, so there's no authenticated user that created a SAML token, but we have an access token that gives us the app identity. And then it might also have the user identity inside. So here's this picture right here. So let's say that SharePoint farm is just standing around doing nothing. All of a sudden, this call comes in through a CSAM REST entry point. The first thing that SharePoint says is there a SAML token? If there's a SAML token, well, then we look at the URL and does it target an app web? If not, plain old user authentication the way it's worked in SharePoint 2010. However, if that call targets an app web, then SharePoint uses the internal authentication to authenticate the app, establish its identity, and it assigns the user identity as well. Note that with internal authentication, you cannot have app-only identity. App-only identity allows your code to run as only the app. So if your app has permissions and the user doesn't, the app can do things. So that's your elevation. But the point I'm trying to make here is that with SharePoint-hosted apps and client-side code, it's not possible to do. You have to be writing server-side code to be able to get that elevation technique. Okay, now let's look at the case where a call comes in, SharePoint looks at it, there's no SAML token. The next thing it does is says, well, is there an access token? Now, the access token might be a OAuth access token or an S2S access token. Let's not split hairs between those now. But what it does is it says, okay, there's an access token. We know we're going to use app authentication. And it looks inside the access token to say, is there also user identity? And if there is, it sets up the call context with both app and user identity. And as a developer, if you've created an app-only access token, SharePoint will then set up the call with app-only identity, which allows you to do elevation above the privileges of the current user. Okay. So now that we've been through some of those fundamentals, let's talk about how permissions work. So we track user permissions in SharePoint 2013 without any big changes from the previous version. So user permissions are mainly managed at the site collection level in terms of securable objects that are arranged in a hierarchy. And the one extra thing that we can do, kind of above the scope of the site collection, is you can go to your web application and create a user policy for this user to be able to read all the different site collections. Well, now, how does app permission work? So app permission is managed completely independently of user permissions. There's no hierarchy, and app permissions are assigned permissions at a particular scope and a particular type of permission. So the different scopes that we have is at the web, site collection, or tenancy level. Now, next thing we're going to see here is that there's three different types of permission policies. There's app plus user, which is the common case when an app calls into SharePoint. And remember, both the user and the app both need the permissions that are required for what the call is trying to do. And if either one lacks, the call will fail. Okay, now, there is app-only policy. And that's the idea of the app has permission, doesn't matter if the user has it or not, and it's only allowed in server-side code where you do explicit programming, and instead of getting a standard access token, you get an app-only access token. And we'll see in just a second, you have to do a little bit of stuff to configure the app to request to be allowed to use app-only policy. The last one, user policy, doesn't really involve apps. It's just when a user calls into a site, it uses user policy. Okay. Now, apps, by default, have permissions on the app web, full control, and then some very limited read permissions on the site where they were installed, or in other cases, if the host site is not the site where installed, have some permissions there. But most of the time, the app is going to have to request permissions by putting XML in the app manifest. And the idea is that when someone installs the app, SharePoint then says this app requires permissions 1, 2, and 3, and that installing user then has to grant the permissions. Now note that if the app is asking for a permission that the current user doesn't have, that user can't grant the permissions. The user requires the permissions that the app is requesting to be able to grant them. Now, also note that when you install an app and it requests permissions 1, 2, and 3, you can't say, I'll grant permissions 1 and 2, but not 3. It's an all or nothing proposition for you to grant, and if you deny, the app doesn't get installed. Okay, now, here's what permission requests look like. I'm not sure why my code is so small right there. Oh, I know why my code's so small. I'm using one of those really modern animations. So basically, here's what the app manifest looks like at a high level. Now, what's nice about Visual Studio is it puts this friendly app manifest designer in place. So you can basically just go to one of these particular tabs right there. And if you've been using the Visual Studio tools that were out during the beta, you'll notice that these are different. So this week, the Visual Studio team has announced that they have this new Preview 2 tool set. So basically, the ones that people have been using over the last couple months were not tested and tightened up against the RTM version of SharePoint. So the Visual Studio team this week basically announced and made available the Preview 2 tools. And they're going to take another month or two to tighten those up and kind of give us a released version, but now there's something that you can download. Now, notice that there's a couple different tabs. There's a General tab, a Permissions tab. If I move over to the Permissions tab, what we can do here is we can use these friendly user interface pieces to add permissions. And what happens is behind the scenes, they're going to add app permissions here. There are many cases where the developer can just use the designer and doesn't need to view or edit the app manifest.xml file directly. But in other cases, you will have to go in there and make manual edits. So when you have a permission, you have the scope, the product. There's something like content, which is the provider. So SharePoint has a content provider, has a search provider, BCS, and then there's a particular type of permission inside there. Okay. Now also note that if you want to use app-only permission, not only are you going to have to acquire an app-only access token, you're also going to have to put the request into the app manifest, and you're going to have to do that by going into code view and putting in the allow app-only policy equals true. So the idea is when your app has these permission requests inside of its app manifest, and someone installs the app, that installing user is then going to be prompted with this UI. Do you trust this particular app? And it lists the permissions that you're requesting with either a trust it, which you're then granting all the app permissions that the app is requesting, or you click cancel, the app doesn't get installed. So remember, there's no partial granting. It's an all or nothing proposition. Okay. So let me move over to my demo machine here. And inside of my demo machine, let me go ahead and close this down. I'm going to go back over here. I'm going to open up another project that I have. And this is my app permission demo. So with the app permission demo, if I look at the app manifest, I can look inside there and do I have permissions inside? If I come back to the app manifest, I can also view it inside the designer. It looks like I've done something to break the designer. Not sure what that is. But let me go ahead and remove this permission request inside here. And let's go look at some code, because I have some code, and my code is going to try to do something that requires permissions. So this code is going to get a hold of the top-level site, basically the site collection, and try to call at the site collection level and get the title of the top-level site, which is not going to be something that's allowed from the default minimal set of permissions given to an app. Okay. Now, if I come back here with this, and let me see, I think I might have got one of these. I think I copied this project. No, that's not it. Give me one more second here to switch over to, okay, I must be using this one here. So I'm going to go back to my dev site. I'm going to take this particular app and make sure that my app gets targeted to this particular site. Now let's go ahead and hit the F5 key so I can kind of go through the process. And so now it's going to install the app into Office 365, and we should see the default behavior of SharePoint when a user attempts to install an app that is requesting permissions. I find that this takes anywhere between 7 and 127 seconds when you want to install the app inside there. Okay, so basically the first thing I get is this right here. Do you trust this particular app? And if I trust this particular app, I come inside here, and so now my code is going to try to call to some specific place. And it looks like I've got a little issue here. And while I didn't mean to have this issue, I think I can point out something that gets to be important. When you're testing app permissions, quite often when you stop the app and Visual Studio does the retraction, it doesn't do it all the way. What I find is much more reliable is just going inside the site, going to site contents, and then taking your particular app and explicitly removing it from here, which will then give you a far more reliable way to purge any information about the app from a previous debugging session. I'll wait till that thing goes away. Okay, now let's try it one more time, where we'll shut that down. We'll make sure that my app manifest okay, so that was actually the problem I had there. Let's go ahead and get rid of that. Okay, so I wanted to show you failure then success, but I'm going the wrong way. I guess I showed you success and now showing you failure. But the thing that you're going to see here is that when the app tries to make a call, whether it's a client-side call or a server-side call, and it doesn't have the app, it just basically gets an access denied error inside there. Okay, so now it should install the app right here. Once the app gets installed, notice that it didn't prompt me because I didn't ask for any permissions. But now I try to run this code right here, and I don't have any permissions. And notice that whoever I try to log in as, even if it's my proper credentials, it's going to get me into this loop where it just kind of keeps asking me for credentials, and it doesn't work until finally we come back here and my JavaScript code or my C# code. The C# code would be more straightforward because it's not through the browser that has this try 3 times to get the correct credentials and resubmit. But basically, we can get those inside there. Okay, and I think I'll just kind of stop the demo at this point because I've already kind of showed you the case where we have success and where it prompted. Okay, so now we are at a point where we have gotten the app installed, we've gotten permissions, and so now we can start drilling down on how OAuth really works. Okay, and we'll kind of look at the theory and kind of the high-level view of the OAuth protocol handshake in the first section, and then we'll get into a lot more development details in the second section. Now, Microsoft didn't create OAuth. OAuth has actually been around, for quite a few years. And before we had OAuth, we had things where we have different applications on the internet, and I go to one particular site, and this site says, oh, by the way, if you can let me into Facebook, I'll go ahead and I'll take this picture and post it there for you. But what we need is we need some type of ways, for one website on the internet to be able to have some type of controlled access to another website on my behalf. And what people tried, with the first generation was just, why don't we give website 1 Ted's username and password so it can call into website 2 and authenticate? Well, that solved the problem. It created quite a few other problems. So when I give away my username and password, it authenticates as me. It has all my permissions, and if it does something bad and someone says, who did that? It says, Ted Pattison did that. The other problem is, what if I then give my username and password to 10 websites, and then one of those websites goes rogue and I don't like it? How do I pull things back? Well, you can't take back a password. You have to reset your password, which means then you have, configuration issues to reset the password in those 9 other sites that weren't creating a problem. So what they did is they created this protocol which is called OAuth, to be able to solve that. Now, there's actually 2 different versions of OAuth. There's OAuth version 1.0, and that, is, has been used, it's still being used, but some people thought it was too complicated, and so they started a second branch, which is OAuth 2, and they're very different from one another because OAuth 2 adds simplifications for programmers and tends to be something that is easier to implement. So OAuth is used by things like Facebook, Google, Twitter, when you're kind of configuring app permissions inside of those environments. And so when they created SharePoint 2013, and they knew they had to create some type of external authentication mechanism, OAuth 2.0 was selected. So there's an OAuth spec you can go out and look at. And certainly Microsoft, as they implemented OAuth 2 inside of SharePoint 2013, had to look at the spec to basically see how to build the access tokens that were going to be passed in. And there's a lot of other issues that the OAuth implementation has to deal with. Okay, remember that OAuth is mainly used in Office 365 environments. However, it can be configured for on-premise farms. Though Microsoft hasn't given away many of the details yet, they're still trying to firm those up before they tell us how to connect our on-premise farms to use OAuth. But OAuth in SharePoint 2013 requires an authentication server, which is Windows Azure Access Control Service, ACS. And the idea is that the remote web has to communicate with ACS because that's where it gets its access tokens. And then once the remote web has acquired the access token from ACS, it can basically pass them to the SharePoint host, and the SharePoint host can basically look at the access token. It can authenticate it came from ACS, and then it can use it to authenticate the app identity and optionally the user identity as well. Now, at a high level, there are these concepts in OAuth that are important. There's the idea of the content owner. So to kind of ground that in SharePoint 2013, that's going to be a user or a set of users, who use the particular site where the remote web wants to access content. They have to be privileged users because they have to, have the permissions that they grant to an app. Well, there's the content server, which is basically the SharePoint server. In our case, it's going to be the SharePoint servers inside the Office 365 farm. There's the client app. And the client app is basically your remote web. Now, there's this dyslexic thing that goes on where they talk about the app ID and the client ID and the app this and the client that, and they should have used one term. But just realize app ID, client ID, same thing. They should have chosen one, but you're going to kind of see them bouncing back and forth, unfortunately. And then there's the authentication server. So that's the one that basically is trusted by all parties, and it's going to build the access tokens. Okay, so Windows Azure ACS, is the authentication server. And in a second, I'm going to show you an animation that's going to go through this in a lot more detail. But at this point, what we're going to see is the content server, is Office 365, and it's, SharePoint 2013 tenancy. There's my client app, which is a remote web that runs somewhere, and both of those parties are going to need to access ACS. Okay, now, next thing we have to do is we have to understand this idea of an app principal. An app principal typically has to be explicitly created, apart from us creating and developing the app. But the app principal is, what the SharePoint farm uses to identify the identity for a particular app. And when we register an app principal with the SharePoint farm has to also push information into ACS, so ACS knows about it as well. Now, there's a couple pieces of information that we need when we register an app principal. We need the client ID, aka app ID, which is a GUID-based identifier. You need this special secret, this special key called the client secret. And the idea is we have this little key that two parties get. The remote web gets a copy of the secret, and ACS gets a copy of the secret. And the idea is that they're the only two parties that have the secret, and each one can use the secret to encrypt data, and the other side can basically decrypt it and basically see things that no one else can see, and they can basically authenticate one another because of this app secret. Now, your remote web also has to be served out of a particular URL. So there's an app host domain, and that has to be well known to ACS, because it's not going to create an access token if an app calls in and basically says, hey, here's my client ID, you want an access token. ACS would say, well, wait a second, that client ID points to this URL, you're coming from this URL, something seems fishy. So basically we need to have that app host domain. And then finally, there's something called a redirect URL, which only comes into play in the very last thing I'm going to show with on-the-fly permission requests. Okay, now, there's quite a few different types of tokens that we're going to be using. The first is a context token. The context token is something that ACS creates and passes back to SharePoint, and it has information about the current user, about the current SharePoint site, and the idea is then SharePoint can then propagate the context token to the app, and the app can basically see what's inside there. Well, secondly, there's the refresh token. The refresh token is something that the app can use to call into ACS and say, give me an access token. The access token is really the security token that SharePoint requires when the app calls into it from the remote web. And the final thing we're going to see in the very last section is something called the authorization code. And the authorization code is basically something that a website can request so it can get permissions to SharePoint without having to be installed as an app. So let's worry about the first three for now, and let's kind of defer more talk about the authorization code to the last section. Okay, so now let's walk through the entire protocol. We have this client app. We have an app that's installed. And so we have a user, and the user sees the app in a tile. Now, in order to create that tile, what happened first is that that user running in the browser called into SharePoint, and we just did a standard user authentication, and we created a SAML token. Now, the user's at a page, like the site contents page, that has an app tile, which is a JavaScript component that has the context token. So in order to create the app tile, SharePoint has to call into ACS and say, hey, I got a user, John Doe, and he's using site 123. Can you please create a context token? That gets passed back to SharePoint, and then SharePoint basically adds that to the JavaScript code behind the app launcher. What happens next is the user clicks on the app launcher, and the JavaScript code then posts to the remote web, passing the context token. Now, inside of the context token, there's enough information, including the refresh token, where the app can now call into the authentication server. Now, also realize that the ACS server and the remote web both have that secret. So when we created the context token and gave it back to SharePoint, it was signed with that client secret so that only the app that has the secret would be able to read it. And so by the time it gets the context token, it requires that client secret to be able to pull out the information and get what it needs to be able to call back into SharePoint. Also, the client app, the remote web, then is required to take that secret and encrypt data as it passes it to ACS and asks for an access token. Well, now the access token gets returned back to the client app, and once the client app has the access token, it's party time. It can basically just call into the SharePoint host site using either CSOM or the REST API. It will then see the access token, and basically it will then authenticate the app to an established identity. And if the app and the current user have enough permissions, the call succeeds. If not, access denied. And the idea is then the app can get any information it wants back, and then it could basically find information about a SharePoint list, build HTML, and return it on the page back to the user. Okay, so that's just kind of a high-level walkthrough of how things work. So next demo I'm going to do is real quickie. I just want to create a very simple auto-hosted app and hit the F5 key. And what you're going to see is that so many things kind of fall into place automatically with auto-hosted apps. And then in the next section, we'll see that we have to do a lot more work when I'm doing a provider-hosted app. So the steps to putting all this together: create a new cloud-hosted app project. And once again, if you're going to be doing it against the current version of Office 365, you can't use the VS SharePoint tools that were available as of June or August. You have to use the ones that just got released at the SharePoint conference here. You also have to register an app principal. Now, since I'm going to do my first demo with an auto-hosted app, can't be easier. It gets registered automatically. But registration is going to require explicit steps for provider-hosted apps, or for provider and auto-hosted apps if you publish them into the SharePoint Office store. Okay, and then we're going to have to add code into the remote web to basically get tokens and basically attach the access tokens to outgoing requests. Okay, so let's go ahead and jump into yet another demo. Okay, so let's go back here, and I'll create a new Visual Studio project. And since I got such a great reaction to our favorite horse, we'll go ahead and use that as the name again. So I create this new project right here, and I basically say, there's my developer site, and I'm just going to take the default, which is auto-hosted. Let's go ahead and choose Finish right here. Now, it turns out that I can just hit the F5 key. And they've basically put the required configuration and the required starting code just to make everything happen. Now, first of all, let's look at the app manifest. I look at the app manifest, and what I see is that we have auto-deployed web application, which means auto-hosted. If I look at the web.config file, notice that it doesn't have a client ID yet. The client ID is going to be created when the auto-hosted app gets installed by Office 365. Now, I do need the secret here. And what's going to happen is Visual Studio is going to work with Office 365, and when Office 365 creates that GUID, it's going to pass it back to Visual Studio, which will then update your web.config file. And then finally, if I take a look at this code right here, here is the hello world code, to get a context token. And let's look at that in a second. But for now, let's just hit the F5 key. I hit the F5 key. And now it's going to take my auto-hosted app. It's going to install it into my Office 365 developer site. And notice that Visual Studio makes it really easy. You don't have to stand up, your remote web, at a real domain on the internet or on your network, because you can just basically just get by with using localhost when you're in the development environment. Okay, after this completes right here, it's then going to prompt the user to basically grant certain permissions. And then what we'll see is that the app has already been installed. There's already a remote web that has been stood up. Okay, so if I go back over here, before I do that, let's go back over here. Hey, someone just updated my web.config file. I go look at the web.config file, and you can see that this value is the one that Office 365 kind of credited on the fly for the auto-hosted app. Okay, so now let's go ahead and trust the particular app. And as I trust the app right here, a little bit anticlimactic when you look at the UI itself, but let's look at a little bit more detail here. Let's say I go back here, and let's get rid of all these things. Let's take a couple of risks here. Let's go ahead and debug right against Office 365. Remember now, the remote web is just running right on my machine, localhost. Hey, let's go ahead and set a breakpoint right here. And so let's go back here, and let's go ahead and refresh this particular page, and boom, it falls inside here. And one of the things that we should be able to verify is that when we click that particular tile to go inside here, it basically posted to my start page and gave me a whole bunch of different variables that are inside that we'll look at in just a little bit. But then the next steps that we have is that I'm going to use this class that Visual Studio just basically adds to my project, which is the token helper. And they have this one particular thing called get context token from request. And so let's go ahead and hit F10, step through that right there. And now we'll basically say get client context with context token. Let's go back here. Let me kind of empty out what's inside here. Let's go back now, and as you make this call as a developer, what's going to happen right there, what we're going to see here is that you've just called this particular method, and as you did that, it tunneled over to ACS. It basically made just a REST request, basically saying, hey, here's some information, here's the refresh token, signed with a secret, and ultimately what's going to happen is that the access token, gets passed from ACS back to your client application. And so now the client application can just use CSOM. In this case right here, I'll just hit F5, client context, execute context. And what we could see here is if I look back inside here, here's using the client object model, but there's this header, basically that has the access token inside of it. Okay, so now you've seen how all those pieces, fit together, at a high level. I'm going to go ahead and stop this, move back to the slides, and go into a lot more detail about, what we have to kind of get our hands around as developers. Okay, so when we're developing external apps, and in particular, auto-hosted apps or provider-hosted apps that are going to be used in Office 365, well, I have to manage app principals. And only in the case where you have an auto-hosted app and you don't plan to ever publish it inside of the SharePoint Office store, can you get away with just having, basically Office 365, create the client ID for you and automatically update the web.config file. So there's a couple different pages that are built into SharePoint. And I'm going to show you what these pages are. App Reg New, App In or App Inventory, and App Principles. Now, also note that if you don't want to do it through the UI, there's also a set of PowerShell functionality in PowerShell for Office Online, and that was out in beta, and it seems not to be released yet by Microsoft for RTM. But the idea is that you can install these PowerShell commandlets and the support for them on your machine, and then use PowerShell to reach across the network, make a connection to your tenancy, and basically do your management of apps and app principles using scripts instead of going through the UI. Now, here's the App Reg New page. Now, when we use App Reg New, let me switch over just for a second here to my site. And inside of this particular site, let me go back to my browser. And here is my particular site. So notice that there's no links to get to these things. So you have to just come up to the site, _layouts15, and then we're going to say something like app reg new, just type it in directly, and then you'll get to this page. You can put in your app ID and your app secret, aka client ID, client secret, or they just kind of provide the convenience of you clicking on these right here, and then putting in the title, putting in the domain, where your remote web is going to live, and then optionally putting in this redirect URL as well over there. There's also a page which is also after you click create, it gives you back this page, and now you're supposed to take this information because you're probably not going to commit it to memory by looking at it once. Copy it to notepads just so you can have it put in your things like your web.config file. There's also the app inventory page. And this page allows you to either overwrite something or you could use it to create a new one. But the idea is you can put an app ID inside here and click lookup. And when you do, it will basically bring back the information inside. And then finally, there is an app principles page. This probably doesn't have the best name. It's really the app principles that have been registered, then they have been used and assigned permissions to them. So if you create an app principal, but you've never used it and never assigned a permission, you won't see it inside this page. You have to go to the PowerShell to kind of get the full control to delete app principles that you might have added by mistake that you don't want anymore. And I can't find a way with a current build without the PowerShell tools being available yet to get rid of app principles once you've added them. Okay. Now, there's also this place that we can go, which is basically the developer dashboard or the seller dashboard. And the idea of the seller dashboard is that if you want to create SharePoint apps and you want to publish them inside of the App Store, well, that's great. You basically have to upload the apps there. They have to meet certain criteria. Microsoft has to look at them, make sure you follow certain guidelines and whatnot when you're using them. Now, so there's this place we can go to, which is basically seller dashboard at Microsoft.com. So when you want to add a new app, you can basically add it. And the idea is you've already gone through your testing. But there's also client IDs. So if I click on client ID right here, notice that I have client IDs. I can basically request a new client ID. And so what's going to happen is that you're going to fill in information about what's the friendly name of your app ID, what's the app domain it's served out of, what is the redirect URL, and do you want it to last for 1 year or 2 years. Note that you do not provide the client secret. But when you click create, it creates the client secret and hands it back to you. And now you have your client ID and your app secret that then you have to actually add to your web.config file. Now, let's look at the different places where these things have to go. That first demo I did, well, I didn't have to do much because basically the app manifest just says, I am an auto-hosted app, and I don't have my client ID yet. It gets created by Office 365 during app installation. Now, inside of the web.config file, as you saw in my previous demo, there was no client ID, but as part of installation, since it's creating the remote web, it takes your web.config file and automatically updates it with the right client ID value. Now, for provider-hosted apps, things are different. In the provider-hosted app, when you're developing, you can get away with the ~remote web URL, but by the time you ship, you have to basically hard code in, the URL to where your remote web lives on the internet. And then secondly, you have to add in the client ID. Only in Vegas can you run GUID-gen late at night and get back a GUID that looks like that. Okay. Okay, and then also, inside the web.config for the provider-hosted app, these things have to be added ahead of time as well. Okay, now, let's talk about when the context token gets pushed along with other things to your app, what do you get? So the next demo I'm going to show you, I have just this little sample app that basically just grabs the data that's passed from SharePoint to the app and basically makes it so you can see it and visualize it. So there is going to be this post variable, which is SP app token, which really should be called SP context token. That's the context token inside there. They also pass you the SP site URL, which is basically the URL back to the host web from which the app was launched, along with other related information inside there. Okay, now, when we look at the context token, it's basically this big string, but in the demo that I have, you can use the token helper class to basically rehydrate it as a JSON token, which then allows you to see information that's inside. So we have things like the realm. The realm is the tenancy. So for my particular scenario, that realm identifies my Office 365 tenancy. Okay. You're going to have a different tenancy, for any other, or different ID for any other tenancy. You have the security token service URL, so that's basically how it gets to ACS. The target principal name, which is basically another identifier for ACS. And you can see that the context token is valid for 12 hours. And then they also pass this thing called the refresh token. And the idea is, if you hold on to the refresh token and you store it in your database, that thing is good for 6 months for you to be able to go and basically get access tokens. Okay. Now, when you get the access token, what information does that thing have inside there? That's got things, mainly it's just a big blob, that you're not going to be able to make any sense of, but you're going to basically just, send to the other side. But there is also going to be a expiration. Once again, access tokens, are good for 12 hours, and that's why you have to hold on to the refresh token if you ever want to create, something that, is an ongoing thing you want to do past a 12-hour point. Okay, now here's the code that we're going to have to acquire access tokens. Now, one of the things that you're going to see is that your start page is the thing that gets posted to with the context token. That's got the refresh token. But then your start page is probably going to navigate to page 2 and page 3 and page 4, and so how are those other pages going to get the things that they need? So you probably want to use some type of a caching technique. Now, I'm not suggesting that the way I'm doing it is the best way for all scenarios. So I'm just going to add things, inside the ASP.NET Cache object. You could use sessions. You could use cookies. You have to worry about passing sensitive information across. Let me go back a couple of slides and point out that in the context token, there is this special thing that they pass you, which is called the, sorry about that, which is called the, stop that. Okay. Okay. Somewhere inside here, if I go off and back on. Okay, so here, the thing that and now that I want to write it, can't write to it. Okay, well, this thing called the cache key, it's passed, and that is a key that is unique for every combination of user and realm and remote web. Now, it doesn't include site. So if you're going to go for multiple sites, you can't use it. But what you could do is you could basically just create something and append that onto it and put it in the cache. And then it's going to be different every time there's a different user. So you don't have to worry about grabbing the same access token for Bob when Martha's the one who actually made the request. And that's exactly what it's meant for, is for us to use some type of brilliant caching scheme that we've created on our part. But the idea is you just have to make the access token available when you want to call into SharePoint. And whether you've cached the access token or whether you have the refresh token and you get a new access token when you need one. So when I want to make calls, and I want to make those calls in, what we're going to do is we'll start with REST. And when I'm using REST, well, I'll go ahead, and this is a server-side call. I add the authorization header, and then at the beginning of the authorization header, I put in bearer space, and then I put in the access token, and then I basically just make the calls, and the access token flows across with it. When I'm doing CSOM calls, it's actually easier. I basically just call get client context with access token, and it automatically caches the access token and basically adds it the same way, in the header as it calls across the network. Okay, so let's go back and do yet another demo. So in this case right here, let me leave this page, go back inside here, and let me now go to the demo that you were just seeing on the slides. So in this case right here, a couple things to point out about this demo. I want to show you at least one demo with a better UI. So here's a case where I have a master page. And when we look at the master page, it's doing things like including jQuery and jQuery UI, and also this remote web master.js. If we take a look at the remote web master.js, what we're going to do is we're going to leverage this JavaScript component that comes with SharePoint 2013, and it's kind of meant for us when we create remote webs and we want our UI to look like SharePoint. So I call into SharePoint and I download this script, spui.controls. I'm using the debug version. And then I'm going to call new on the spui controls navigation. This is what we call the Chrome control. And you're going to see what the Chrome control is going to do for us. Okay, so let's go ahead and hit the F5 key here. And this thing starts running. And there's code behind default.aspx that is going to get the context token from the request. And then once you get the context token, which is going to be passed as a big string, there is a token helper method, which is read and validate, which basically takes in a string and then passes you back a strongly typed object, which is basically the JSON form of the context token. Okay. Other things that I'm going to need is I'm going to need to get the URL back to the host web, and that is passed to you as a query string variable. I need the target principal name, which is part of the context token. I'm going to need the realm, which is also included in the context token. And then when it's time to get the access token, I can just basically call get access token. Now, in addition to that, what we'll see is there's a second method, unhandled script inside here, communicating with SharePoint. Hopefully this error will go away. Okay, let me break and try that one more time. And once again, quite often, this is caused by the thing being installed and not properly uninstalling. So if I go back to site contents, I go find this. Look at that shiny, cool little icon there. Okay, let's go ahead and remove that. And so I think that should make my testing more reliable. And once this thing gets removed, seems like I got 11 minutes left, plenty of time, as long as you disappear in the next 10 or 15 seconds. There we go. Okay, so one more time, we'll go ahead and hit the F5 key. Deployment errors. What kind of deployment errors? Uninstall. Okay. What did I do here? Okay, let's see if I can do a Control F5 instead of an F5, just so the JavaScript debugger doesn't complain. Okay, this is the... Am I using the wrong version of this thing? Okay, give me one more second here to see if I can save face. Mm-hmm. And of course, shutting down Visual Studio, starting it back up, is always highly recommended when your demo is bombing unbelievably in front of a huge room with a couple people in it. Okay, so one more time, let's see if we can get this thing running. Okay, so I go up and I run this right here. There's the output window. Okay, things look a little bit better. It's not failing instantly, so I think just Visual Studio went a little bit wacky there. Now, note that all the code that I'm showing in this session, my other sessions in the slides, I've made available to you on my company's website. I'll show you where that is in just a second. And you should just, excuse me? You do have to give us your email address to get this code. Or you have to fool someone to basically use their email address and have them say, okay. Okay. But you could basically send your don't spam me email right after that first one comes. Okay. If this was all done, I wouldn't be giving you a hard time right now. I'm just trying to fill the time here as this comes up. And this will be the exciting second to last part of the session. Okay, we're over a minute right here. What was great during the beta is that if you basically had a external authentication app, provider-hosted app, and it didn't have the client ID, and you hit F5, it would just basically go up to 10 minutes, 15 minutes, 20 minutes, and there was no way to stop it from running away. Okay. I still have confidence that it just might take a minute and 47 seconds to be able to run inside here. Okay, we'll give it to 2 minutes. I still have 8 minutes left and 5 minutes of content. And so if this comes up in the next couple seconds, well, I didn't make the 147. So obviously my site's getting a lot of traffic right now. Okay. The other thing that you can always do is just go somewhere else, and then it says, wait, don't go away. I'll work if you're about to go away. Okay. What I'll do is I'll monitor this, and I'm going to go to the last section here. Oh, see? It happens every time. You go away, and then it gets, oh, no, I didn't think you were going to go away. Okay. Anyway, so let's go ahead and trust the app right here. So first thing we'll see is that the Chrome control automatically gives us the ability to have a link to our home page and something that's required for all apps to have the back pointer back to the other site right here, so that you can kind of go back to the host site and then go back to this site right here. It also provides the ability to go to these other pages right here. If I go ahead and click on like the help link right here, I can get to a help page inside. Okay, now once again, let me just kind of step through the protocol here. So let's go back, and the user is about to launch my app. Okay, so once again, let's go ahead and bring, if you get this thing in the background that tells you there's an error, it's because Visual Studio has this tendency to bring up some other website that we're not using, and it fails because we're using some other website. So generally, when you see this, you can ignore that. But what I wanted to do in this last part of the demo right here, once again, let's bring up Fiddler just so we can kind of see the pieces in play. And so as the user comes here and clicks on this, what's going to happen? And we can see, this set of calls that's going on right here. It basically is calling to ACS, getting the access tokens inside here, and then it's also going to be, making calls into my SharePoint site. Okay. Now, once again, I just wanted to put together this app so you could see the different things like the incoming data. So these are all form variables and query string parameters. There's the context token with the information and information about the access token. And if I come down to these other pages right here, what I wanted to be able to do is, make it so we can call into these pages and see these calls in motion right here. And inside of the app web, if we look at something like the the REST call page right here, there's the same code in the slide where basically I'm going to grab the access token out of cache and basically add it inside here. And the big thing that we get, when we do that is when the calls go in there, they basically have the correct headers inside there with that access token inside. And basically, the same thing for when I use CSOM. And let's go back here. Let's go ahead and go to the page that makes a CSOM call. And it's going to be a little bit different, in the fact that I don't control the entry point. CSOM always hits, client.svc process query, but you can still see the bear inside there. Okay, so now that brings us to one more section, 4 minutes to go, plenty of time. And we're going to talk about developing external apps that use OAuth. So the scenario is, I have a website, and it's not installed as a SharePoint app. And so what we can do is we can basically have that external website basically call in and say, hey, can I have permission? And what's going to happen is it's going to then prompt the user with a page so a user can either grant or deny. And if the user grants, it basically passes back what's called an authorization code. And that's going to allow the user, the other site to be able to use the access code. So for this particular demo, the way I have things set up is the first page is going to redirect to the OAuth start.aspx page. That's a page I created. Now, inside of this particular page, what we're going to do is we're going to call to token helper get authorization URL, and we have to pass what's the host web. We have to pass what permissions we want, and then here's where the redirect URL comes into play. We have to pass the redirect URL. Now, you're going to have to go and register a client ID and a client secret. And what's going to happen, I take that back. You have to register the app principal with a client ID, but there is no client secret in this. Basically, the client secret is not needed because of the way that the user has to kind of be involved to click the trusted button. But then what's going to happen when the user says, I trust this app or this website, the call gets returned back from SharePoint to that redirect page, and as a query string parameter, it passes the authorization code. And then it can basically just use the authorization code, which by default is good for 6 months, to call into the SharePoint site. Okay, so one more time, we will go back here, and this time I will say open, I got to stop this guy, and open website. And now I have this website inside here. We'll go ahead, we'll open this guy up, and here I've configured this on my local machine, but I'm not using localhost anymore. And so we have this first page. As you've seen, it's got a hyperlink to point to this page. And when we get to this page, we're going to basically request the authorization URL. Okay, so we'll go ahead, hit F5. And as I hit F5, let's go ahead and use Reflector to make sure things are working properly. So this is the Superfly SharePoint Assistant, because it's going to get the things on the fly. So I click here, and now I go to this page, and just to kind of say what's happening here is you use the token helper, and you get the authorization URL, and then you instantly use response.redirect to redirect the client browser to the authorization URL. You can see there's all kinds of things inside the query string. And now, if the user says, trust it, what's going to happen is SharePoint knows where the redirect URL is. And what happened here is that it sent content back to the app server inside here with redirect accept. You can see all the different parameters, including the authorization code. And so the idea is once you have this authorization code, stick it in the database. It's good for 6 months. And that authorization code basically pins you to a particular domain. So your website can't change domains and use the same authorization code. And a lot of other specifics about it as well are going to be required. And the last piece of code that I will show you here is let's go look at what's behind the redirect page. So typically, you're not going to put the code behind the redirect page, but I wanted to keep the code simple. The redirect page is then going to get the authorization code and stick it somewhere where other pages can get it. But the idea is that once we get the authorization code, we can now call get client context with authorization code or get access token with authorization code. And we have to pass the URL to the host web. That's the place where I got my permissions. The target principal name, which is always going to be the same for Office 365. The authorization code. The target realm. So basically, that's the ID of my Office 365 tenancy. And the URI redirect accept URL. Because if it posted to one particular redirect accept URL, when I call back into it, I have to know what URL it sent that back to, and it wants to see those things map up. Then you get the access, or the authorization code, and then basically just use CSOM and the REST API as usual. Okay, so how easy was that? Simple as pie. Okay, so let's go ahead and conclude. We now are done with all the different pieces right here. The last thing that I want to show you, then I promise I will let you leave to go to your next session, is that if you go to Critical Path Training, a site where incidentally you can also purchase training, and you go to our members section, so click once on members, and then click on presentations, and basically there's a zip file with all this code and the code from my 2 other sessions and all the slides. As this gentleman pointed out, it is protected with, you need an account, you have to give us an email address, but I just wanted to make things available to everybody. That is all I have to say. I'm going to go to another room right now and give another presentation, kind of like this, but on S to S. But thank you very much for attending.